Welcome to the Shcok Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The topic of this video is shock absorbers. As you may know, there is a spring installed between the wheel and the vehicle body, which supports the weight of the vehicle and absorbs shocks from the road surface. However, springs have the characteristic of continuing to vibrate for a while once they begin oscillating. Therefore, in a car equipped with springs alone, vibrations persist for a while, leading to decreased in-ride comfort. A shock absorber is designed to dampen this unnecessary vibration. When pushing water out of a syringe, significant force is not necessary. When filling a syringe with high-viscosity oil, significant force is required to push the piston. A shock absorber utilizes the resistance, generated when oil passes through small openings, to dampen the unnecessary movement of the spring. A shock absorber is primarily composed of a rod, an outer shell, and a piston with a small hole in the pathway for oil flow. The small hole in the piston is referred to as an orifice. The inside of the outer shell is filled with oil. When the body or wheel moves up and down, the piston travels through the oil. The viscosity resistance generated as oil passes through the orifices functions as damping force. During this process, the shock absorber generates heat. In other words, the shock absorber converts the kinetic energy of the car's motion into thermal energy and dissipates it into the atmosphere. Generally, shock absorbers are mounted in parallel or coaxially with the spring, and are damping the unnecessary motion of the spring to enhance ride comfort. There are several methods to adjust damping characteristics, and one of them is by incorporating valves into the orifices. In this animation, you can see a valve that only opens during extension, and reduce the damping force only during extension. Additionally, damping characteristics are also influenced by the viscosity of the oil. A high viscosity oil results in greater damping force, while a low viscosity oil leads to a smaller damping force. There are two main types of shock absorber structures, monotube and twin tube, each having its own advantages and disadvantages. With various options available such as orifice diameter, presence of valves, oil viscosity, and structure, appropriate shock absorber characteristics are configured for each individual car model. In an electronically controlled shock absorber, an actuator mounted on the upper part of the shock absorber rotates a rotary valve, thereby altering the oil passage area of the piston to adjust the damping force. There is also an electronically controlled shock absorber that uses magnetorheological fluid in oil, and by turning the electromagnet on and off on the piston, it adjusts the flow of the fluid passing through the orifice to regulate damping force. Thank you for watching. If you enjoyed this video, please consider subscribing to our channel. We'll see you in the next video.